So let's move on to solving exponential equations that have a base e now, and those are going to be our next examples. Here's the teacher model. We're going to be solving this equation. Notice we have a base e now, and just remember that's a number just like pi is. So it's 2.71828, something like that, with a bunch of non-repeating decimals. So we're going to be using the same process here. We're going to be looking for, is the base of my exponent isolated? And it is not, because we have that plus 7 that's also on the same side as the base e. So we want to get rid of it. How do I get rid of a plus 7? Well, I do minus 7 to both sides. So that is going to cause those to cancel. And rewriting our expression, we get e with exponent of n plus 3 is going to be equal to 72. So then I want to look at this and think about what base should we choose so that my base is going to just kind of go away. So right now we have base e, and just recall that log base e is very special and very commonly used, especially in science and mathematics. And we actually have a different way of writing that, and that is ln, which stands for the natural log. So I'm going to take the natural log of both sides. Just remember that is base e, so it is going to go to 1. So let's do that to our left side and our right hand side of our equations. And then I'm going to rewrite this. I'm going to use the properties of logs also, so I'm going to kind of bring that down at the same time as I'm rewriting this. So n plus 3 times ln of e is going to be equal to ln of 72. So the next thing that we want to do is simplify anything that we can. Natural log of e is actually just going to be 1, so I can sort of drop that or think about multiplying by 1, which doesn't change the expression. And then our natural log of 72, that's going to be some decimal, and we'll get to that here in a minute. So let's rewrite our expression. I now have n plus 3 is equal to natural log of 72. And then the only other thing that I have to do to the n in order to isolate it is to get rid of that addition of 3. So I can cancel it out with a subtract 3. And then I'm going to rewrite my expression as n equals natural log of 72 minus 3. I want to point out a couple of things, and this is just a common mistake that I will see. Do not take that 72 and subtract 3 from it. That number is not actually 72. It's the natural log of 72, which is some decimal number. So these are not like terms. We're going to have to do them separate. We're only doing the natural log on the 72 part. If I have plus or minus some other number, that does not go into the log. So when I put this in my equation, I'm going to do natural log, that's the ln button on your calculator on the left lower side, and it's in capitals. So I'm going to do the ln of 72. I'm probably going to put parentheses around it, and then I'm going to put minus 1 after that. So doing that in my calculator, I want to make sure that I also follow the directions, which said that they want us to round to the nearest 10,000. So the first decimal place is tens, second hundreds, thousands, 10,000. So what they're asking for is 4 decimal places. So I have n equals 1.27, and then it looks like 6 repeats a few times, so that last 6 is going to round to a 7. Then the last thing that I want to do is check it, which I will do. I'm going to put that all into my calculator though, but this is what I'm putting in my calculator. Plus 3, plus 7, and I want to check and see is that 79. And just to let you know, when I did this in my calculator, I got 79.0024, some other decimals. And the reason why we're not getting exactly 79 is because we had rounded our n number. We didn't take all of those decimals. So it was approximately equal to 79, which is fine because there is always some kind of error when we round. Next, we have a we do. I would encourage you to pause this video and go ahead and try it yourself, and then play the video after you've exhausted all the guiding questions and are still stuck, or if you successfully complete it, then check and see if you got the correct answer. So again, how do we start this? Well, first, I'm going to think about, is my base isolated? Our base here is E. And no, it's not isolated because it's being multiplied by 8. So that's the first thing that I want to do is get rid of that multiply by 8. So I want to do the inverse operation of that, or the opposite operation, which is dividing by 8. So that will give me e to the 3x equals 13/8. And don't fret too much about getting decimals or not getting nice numbers, which we're going to get here sometimes because of that base e. So now we need to select a log base that we want to use. So that always just comes from looking at the base that we already have. So I want to use log base e, which is actually just the natural log, so we can write that as ln. So I'm going to take the natural log of both sides of our equation. I'm going to use our properties of exponents rule for logs that we talked about a few days ago, and write the exponent in front of the log, which I'm allowed to do. Let's see, on the right hand side I get ln of 13/8. Okay, so now I want to evaluate part of those logs. Natural log of e is just 1, so 3x times 1 is just 3x. And then I can stick ln of 13/8 into my calculator. I'm kind of just going to leave it there for now and save the evaluation for the end. So now, the last part that I need to do is isolate my x. So right now it's being multiplied by 3, so we can undo that with the inverse operation of dividing by 3. That's going to give me x equals natural log of 13/8 divided by 3. Don't divide that 13/8 by 3. Make sure that you take the log of that fraction, and then after you've done that, then divide it by 3, or else you're going to get an error in your answer. So I'm going to plug that into my calculator. I end up getting 0.1618. They wanted me to round to the nearest 10,000th again, so that's 4 decimal places. And the last thing I want to do is check my answer. So I'm going to plug that into my original, so 8 base e, 3 times 0.1618, and I want to ideally get something that looks like 13 or is very, very close to it. And I did get something very, very close to it. I actually got 12.9986, with some other decimals I just rounded to 4. So that's close enough. That number that's not exactly 13, that's because we rounded our answer for x earlier. So it's not going to turn out perfectly, but that's enough to confirm that we got the correct answer. On this We Do Plus, I highly suggest that you pause the video and try it yourself. Use the guiding questions, and when you think you have the answer, play the video just to check yourself. Or you could just plug in your answer and see if it makes the equation true. So first I'm wondering, is my base isolated? And no, it's not, because we have that minus 1 over there, so we're going to use the inverse operation and add 1 to both sides. That's going to give me e to the 3m equals 23. Now we want to select a base for our log, and our base here is e, so we're going to do the natural log, which we can write as ln instead of log base e. So doing the natural log on both sides of the equation, and I'm going to rewrite the power in front also, and that's equal to ln of 23. So we know that when I have ln on e, that's actually just 1, and 3m times 1 is just 3m, and that's equal to natural log of 23. Now all I have to do is divide by 3 in order to isolate the m. So I get m equals natural log of 23. Okay, so the natural log is on the 23, and then after you do that in the calculator, then divide it by 3. And here's what I get. 1.0452, and that's rounding to 4 decimal places like they asked. They said the nearest 10,000. And of course I'm going to do a check to make sure that I got the correct answer, especially if I'm just solving an equation and it's something that's easy to check. So I'm in my calculator, I'm doing e to the 3 times 1.0452, and then I want to subtract 1 and hopefully get something close to 22. And I did. In my calculator, I actually got 22.0024, and of course the reason why it's not exactly 22 is because we actually truncated that number earlier when we rounded to 4 decimal places, so that's okay. Now go ahead and try the you do, read through it, attempt the problem, and also plug in your answer back into the equation to make sure that you got it correct. After that, there's an error analysis slide. So take a look at that. They made a mistake that students commonly make. Sort of analyze it, put some notes on your paper, and then I'm going to ask that you go to Canvas under discussions, and there's actually a discussion link. Just type something up what you think the answer is. Don't feel like you have to copy whatever the first couple people answer, because usually there may be a couple different types of answers that students will say, and I'll be checking on that later. Okay, and then also there's a worksheet to do that you should get from the sub, and I will take that up when I get back on Monday.